Great. And Jakob, you have the first item today.
Yes, thanks. So yeah, I'm in the middle of doing a little investigation, and I'm still sort of stumbling around trying to understand what I'm doing, because I've, in my experience, that's how investigations work. Like, you can go back and say, we set out to do this experiment and we did it and this was the outcome, but in reality you don't know what the experiment is when you start. Or you sort of have a rough idea what the experiment is, but you don't know exactly how to run it. So I'm still sort of in this state, but it would help me to talk about it and share it with you people, and I'm curious what you think. So, sorry, long preamble. Redis, Sidekick. We are doing this work to have fewer queues because it's better for Redis throughput. And we have another project on the horizon to have multiple Redis servers and have different deployments of the application, have Sidekick talk to different Redis servers. And but like, how soon will we need this? Because the idea is that if we have a more efficient Redis because of having fewer queues, we can process more jobs, but how many more jobs? So this is roughly what I'm trying to investigate. And I'm using the test rig that Craig built last time around when we were looking into this. So yeah, part of what I'm also doing is learning how to use the test rig because I didn't build it, which is a good exercise. So what I should try to talk you through what I'm doing. So I have a single Redis server, which is the same specification as what we use for Sidekick right now. So that's a C2 standard 8-core machine on Google Cloud. So that is the Redis server. And I now have 2 virtual machines acting as clients, and clients do 2 things. Some clients submit jobs, and some clients produce jobs, and some clients consume jobs. And the part I'm still trying to figure out is how to balance those 2 parts of the workload. So right now there's 2 machines that are simultaneously producing and consuming jobs. And the good news is that with a queue per shard configuration, I now have it sort of, it seems to hit a bottleneck at 17,000 jobs per second right now. And at some point yesterday, I was hitting a bottleneck of 22,000 jobs per second, but I don't remember exactly what was different, or I don't understand why. At that point, I was using 1 big machine as the workload generator, now using 2 machines. And so I still don't understand well enough why at one moment the limit is 32,000 and the other moment it's 17,000. But the way I'm observing it now, and this is one of the things I learned, is I got Prometheus working on the Redis server, and I'm just using the Redis exporter, which is integrated by default in Omnibus, so that's very nice. And the graph I ended up using is the one that shows job rates per command, and because that gives you a fairly good indication of what's going on, because the problem with the load generating part is that it's a lot of different processes. And if you have to scrape all of them with Prometheus, you get a very complicated Prometheus configuration, but it's much simpler to have Prometheus just scrape the Redis server. And I just restarted the simulator, and so what we're seeing here is something like 34,000, 35,000 push operations, list push operations, and around 17,000 operations that correlate with jobs being consumed. I actually modified the workers so that they ping Redis, so the pings correspond to jobs that are actually running. So this shows a job rate of, in the order of 17,000. And one weird thing that happened here, because I left this running overnight, was that the whole thing tanked, and another command went up. So let me just show, like, this was running well, and then all of a sudden, job processing tanks and these ZRAM and Z range by score things go up, and I realized that the load generators generate logs, and the disks were full. So we ran out of disk space on the load generator machines, and they and all jobs started failing because they couldn't log. And so I still don't understand well enough how to use. Like I keep running into things like this, which makes it.
Just to jump in there, sorry. The reason for these commands then is that this is the retry set, which is a sorted set.
Yes, right? Yeah, that was I earlier on. I thought I found a very good result, but then also all jobs were failing, and that also correlated with the ZRAM and Z range by scores, because yes, that's the retry set. So I'm still trying to get a good grip on it, but yeah, if I zoom out a bit, here I had a long spell of running at 17K jobs per second, so that's good. And yeah, here there's a spell where it says ping at 22,000 per second. So I did something right there, but I'm not quite sure what I did right. But even if yeah, 17,000 and 22,000 is still a lot more than what we process today, because our job rate is more like in the 1 to 2,000 range. It should be here. Well, that green band, I suppose, tells us what it looks like clearly. And if I zoom out to 7 days, the green band doesn't, or barely goes above 2,000. And the actual rate here is even not even peaking at, it's below 1.5 thousand. So it looks like a single Redis server. This was a very long-winded way of saying that. It looks like a single Redis server can process, like deliver about 10 times as many jobs as we're processing right now, roughly. Sorry, this was very chaotic. Yeah, it's good news. I just delivered it in a chaotic way with lots of caveats.
How do you have an idea how much the payload of jobs, so the arguments and stuff that goes in, influence Redis CPU?
Good question. I think they do influence CPU. Let me see if I have. This is a flame graph I captured just now, where it's a little distorted because you can see the background save in here, and that is not part of the single core work, that runs on a different core. But if you ignore that, you see that very large part is libc write. Well, if you look, so this is 900 samples, 920. libc write is 1,000 samples. libc read is 700 samples. So that means 1,700 samples in I/O and 900 samples, or what is this? This is 586. So about, yeah, 1,700 samples I/O, 1,000 samples doing Redis stuff in memory on the CPU. So it's already doing quite a lot of I/O, and if the workloads are, the payloads are bigger, of course the I/O will take longer, although I don't know how much. That's an interesting, that would not be very hard to vary, because that's part of the workload generator. Like we can just have a bigger argument blob thing.
Yeah, I don't know if that's part of it now. That's why I asked.
I think it uses a fairly small payload, so we could make the payload bigger. Of course, when we get concerned about I/O, I can also try turning on threaded I/O for the Redis server and see what happens there. But yeah, I guess the other part that I failed to mention is that if we don't do this queue per shard thing, then we stall way earlier, around 3,000 to 4,000 jobs per second. So that's
so you're saying that what you've seen in the tests is that without single queue per shard, we stall between 3,000 and 4,000 per second, and with single queue per shard, we stall at about 22.
Yes, 22 was the best. Yes, 22 is the best number. Right now I'm stuck at 17.
Wow, okay.
But yeah. And another thing to keep in mind is that I was talking about this with Sean, how to interpret this, because we're getting alerts at way lower levels, right? Right now we're in the 1.5 to 2 range, and the experiment suggests we could do double the number of jobs. But I wonder, well, my experience is that in these test rigs, usually you can push systems harder than you can in real life, because your model isn't perfect. And another thing I'm wondering is if I don't know if our concern about Redis Psychic is mainly about CPU saturation or things where we see users being impacted. So, and that would mean job delivery taking too long, because it can be that there's an operating range where our CPU alerts constantly go off, but users don't notice, and users don't care if our CPU alerts go off. Users care if jobs get delivered fast enough. So I guess another way to say that is that if I observe 22,000 or 17,000 jobs per second as the saturation number, we'll probably never want to do that, because at that point, the CPU would be is right now the CPU is pegged at 100%, so our alerts are constantly going off, and that's not practical, because are we going to silence our CPU alerts because we know that 22,000 jobs is fine? Probably not, right? So,
well, I think that's not really what we were looking for. Well, I mean, what the experiment was looking for, because I think we were looking for understanding from where we are now, how hard could we push it before we would start to see the next problems? And is that close to where we are now, or how far away is that actually? And I mean, what you're showing here is that it's like, you know, it's almost 10 times as far away than this.
Yeah, 8 to 10 times more, so we can double 3 times.
Yeah, but I think what I was struggling with when I commented on the issue yesterday was it was hard to understand if 22 jobs per second was like something that we could practically take into talking about this. But I think what you're saying now is that, like, on the test rig, it's the difference between 3 to 4,000 and 22,000.
Yeah, and this is the part I'm still honing in on. So I want to have I want to come up with a fair experiment where I can say this is what we get without Q per shard, and this is what we get with Q per shard, and like having a good apples to apples number on to compare, because I think the outcome of the experiment would be a multiplier, saying like we are stalled here, and if once we're on Q per shard, we see this multiplier at the saturation point. And then the other part of my argument is that if at 100% CPU we can do this, then at 80% CPU we can probably do 80% of that. So if we're happy at 80% CPU, and then we're doing, I don't know, 2,500 jobs, and yeah, so to scale it, to suggest that it would need to be scaled down. So then it's more about the multiplier.
Yeah, a way I was thinking of this was, if we do Q per shard, we expect the CPU utilization to go down, obviously, but we also expect it to grow slower, which is what Jakob's demonstrating here. Like, that's why we get so much more headroom, is because of the much slower demand on CPU time as we increase job throughput.
Yeah, another thing that is interesting, or that I find interesting, is that just judging by command rates, a lot of the work comes from the semi-reliable fetcher, and there are different ways to approach this thing, and there's sort of an optimal way to do the reliable fetch that we can't do because we have multiple queues. So it could be that if we can literally get to 1 queue per shard, we can change the implementation of the reliable fetcher into something that is also more efficient on the Redis server and buy headroom that way.
Yes,
I know that I asked,
and fully reliable.
Yeah.
I know that I've asked this before, but please refresh my memory. I know semi-reliable fetcher is something that we wrote, but why did we need to write that? Because we had so many queues.
Because now what? Why did we need a semi-reliable, or why did we need a reliable fetcher in the first place?
Why? It's part of a bigger question, which is, do other people that use Redis need this? Like, it sounds like we built something that we needed. So why did we need this and no one else did? And is it because we use this in a non-standard
Well,
way?
I think
No.
the reliable fetch is in Sidekick Pro, which we can't
Yeah.
use because we provide
Ah,
an
yes,
open source
okay.
Yeah.
distribution.
So we're
Right.
re-implementing somebody else's paid product. That's why
I
we had to
remember
make
this
that.
answer now. Thank you.
Yeah. And well,
I
it's
think the
interesting.
answer to the semi part is more interesting for me as well, because I don't know
Yeah,
that.
yeah, that's probably the one to focus on.
Well, I don't really know the answer. Or I can make up an answer because I've looked at the difference between the two implementations. And what I noticed is that so there's sort of an optimal thing in Redis, which does okay, the idea of reliable
CRBL push thing, like
Yes,
one thing
the
to the other in one command.
The idea of idea of reliable fetch is that you can drop a job on the floor if the Sidekick process crashes. And the problem is right now is that if Sidekick server accepts a job, it's no longer in Redis, it's in the Sidekick process. And then if you take the Sidekick process away, the job is lost. So what the idea of a reliable fetcher is that you have an alternative data structure in Redis that holds the jobs that are in progress. And then if a Sidekick server goes away, you can realize like, oh, it's gone. These jobs were in progress, so we probably have to start them again. So jobs need to move from the incoming queue to the in progress set or thing. And there's an atomic instruction for that in Sidekick, in Redis, which is perfect because then you can never lose the job because it's by the time you get it, Redis already put it on the other thing. But that atomic instruction only works if you pull from exactly one queue. And if you pull from more than one queue, you need to issue that instruction for every queue. So we would have to issue it 400 times. And the code we're using, the reliable fetcher gem, does something naive where it waits 5 seconds in between doing that. So it would 400 times try to safely fetch from one queue and then wait 5 seconds and then try again. So that's not good for latency, and making 400 calls is also not nice. It's better to do one call.
Especially as most of those 400 queues are empty most of the time.
Yeah. So it's a peculiarity of, I guess it's a Redis shortcoming or a Redis design thing that it only wants to do that atomic thing on one queue at a time. But I'm actually curious what Sidekick Pro does, because I find it hard to imagine that Sidekick Pro says, okay, you can only use one queue.
No, but they do mention you can only use a handful of queues. So if like we need to do this operation 400 times or whatever you said with no jobs in those queues, so that's wasted time. If you need to do that 6 times, that's not as good as one, but it's not as bad as 400.
Yeah.
I think they've recently updated their wiki page, or I misquoted it before, because it does now say, I can check that because it's a wiki page. It now says a handful of queues per process, which, we have different processes running different sets of queues. It's just that the catch-all one runs on a ridiculous number of queues at the moment.
Well, one thing they could be doing is that they just have multiple Redis clients, and each of them does one beer popple push, because then you can, if you have a reasonable number of queues per process, you would have a reasonable number of Redis connections per process, and you can work around it that way. But now just reverse engineering Sidekick Pro or reverse imagining Sidekick Pro.
Yeah, but we already did that.
Yeah. And anyway, what I'm trying to say is that it could be that there's also some extra room to be clawed back just by taking a closer look at the reliable fetcher, but we're not even close to that right now, because right now we need to do something about the queues, because we're just stalled on the number of queues. Long rambling story, but thanks. Any other questions?
What are you going to try next to make them experiment more? Yeah.
Yeah, I think
because you wanted to get an exact multiplier. What do you need to do to improve the setup to get that?
I think I'm just going to fiddle a little. Right now, it's a little bit hard to switch between the two different scenarios. So, and I guess yesterday I was trying to use a 60-core machine and run lots of Scikit servers on it, but then I don't know, you start running out of file descriptors and other weird things happen, and then the system misbehaves because of the wrong reasons. So now I'm hoping I can generate enough load with 2 machines. Maybe I need 3 machines at some point. Do I need to remote control all of them over SSH with a script, or do I need to change the interface of the script where you need to press enter 3 times now? So I'm still sort of feeling my way around what is the right way to run the experiment. Yeah. But I guess saying it out loud, making it easier to switch is the most important thing right now. Making that reliable.
That's the thing. When I wrote that script that you are now using and need to press enter 3 times, that makes sense for that experiment, but I don't think it does for yours.
Yeah. Oh, thanks. That could well be. So maybe I just need to refactor a little bit where the core, yeah, where it can do the thing of your experiment and it can also do the thing of my experiment.
Or just copy it.
Yeah, there's a little bit too much copying in that repo. I'm trying to reduce the number of copies. Yeah, I really would like to have this wrapped up by the end of the week. So that's sort of the rough time box I've given myself.
I think
Thanks.
it's been a really useful experiment to do, and it's really interesting to see what's been possible here. It gives me a lot of information for what we need to be looking at past this. So I'm interested to see what where you get to by the time the time box ends.
Yeah, thanks.
I was going to add the thing now that Andrew also joined. I was going to add the thing that I was discussing with Sean regarding aptX measurements for erroring requests. Let me just find the merge request where we were discussing and link that. So right now, the situation right now is, and we have two middlewares. One that we use to record metrics that we use for service SLIs, so the web API and Git service, SLIs, and then we have another middleware that does a measurement for error budget aptX. So the duration, we record the same duration twice with different labels. In the first one, the one for the service metrics, we didn't record an aptX measurement, so we didn't record the duration if the request raised. I don't know if that means that we didn't record it, because I don't know if that app.call thing in a middleware would return normally with a status 500, or if that would blow up and not record. So if it would fall back to the ensure block or not. Yeah. Right now I've got a merge request out to make both of them do the same thing. But I think that's a good first step, but then I would like to talk about what we want that to be actually.
So when you listen to lots of the conference talks, and there's a really good one called How to Measure Latency, or something like that. It's by a guy named Heinrich. I'll find it after this. You'll hear it's very specific. He always says valid requests, and so that's basically 2xx and 3xx, and not 4xx and 5xx. And so we've always known that we don't have that, but I guess the main reason is because of the cardinality of including the status on a histogram. It's just they're really big. Sorry, I haven't read through this request, so I don't know like the context too much.
But you don't need you don't need to include the status code if you want to. If
yeah,
have
you can
two
record
categories, you could just
yes, valid and invalid. But we lost Jakob. But the thing that I was going to say is like actually from a like operational point of view, and just knowing the way that our systems in particular fail, I think that having that like sum of invalid, or at least like the histogram of the invalid things, is still really useful. Just take the problem that we're seeing at the moment with that one endpoint that it returns a 4 something and it takes 30 seconds and we don't know why. And if we didn't have a histogram of that, that would be unfortunate, I think. So I think, yeah, having it as a you know, not excluding it, but having it as a Boolean or very low cardinality label would probably be a good approach.
Well, maybe it also depends on whether we're counting good requests or bad requests, because no, wait, we count those as bad requests anyway because it's a 4xx.
It's
Or
a
not?
4xx, yeah, because it's a.
We don't count that as a bad one, do we?
That's a good one.
We should, yeah. That's kind of the we should be excluding those from the user, because if a user sends us a request,
we should be excluding them from apdex, but we shouldn't count them as
Yeah.
an error
So
either.
a fast 4xx is not a good request, but a
Yes.
slow 4xx is a bad request.
For my question
So-
right now, I wasn't thinking about 4xx request.
Yeah.
We're just thinking about 500. So things that would
Yeah.
raise and be counted. So things that would, be a failure, system failure kind of thing,
Yeah,
but also measure apdex. And I get Andrew's point that like some of these can be expensive. Like some of them, the one that I was
Yeah.
looking into just now was raising a 500, like it would turn into a 500 after spending 5 seconds talking to the
Yeah.
database and failing.
Search control account.
Exactly that one.
I mean, well, there's also the classic failure of timeouts 502s after 60 seconds. Those are a combination of bad request and bad latency.
Sorry, I lost my connection for a bit there, but so I just wanted to go back to what we do right now, which is that right now, if we say that each request can gain a point, and the total score is the number of points gained versus the number of points that could have been attained. So each request could attain 1 point. So we add the denominator is just 1 per request, and the numerator is the number of points we actually got. So at the moment we say, and I'm going to use valid and invalid, but like our definitions of valid and invalid don't match the ones Andrew mentioned. So at the moment we say fast valid gets 1 point, slow invalid gets 0 points, slow valid gets half a point, and fast invalid gets half a point. That's our current model. That's like effectively what happens. There are some caveats with like they're actually measuring 2 slightly different things, but
What's a point?
Sorry?
What is a point?
I'm just using point to mean like this is what
100%.
goes on. Yeah, it goes on what's on top of the fraction is
What fraction?
So the fraction is the total availability score, right? So like the total number of, let's say,
for the request.
Yeah, so say you have 100 requests that all succeed in good time, then you have 100 divided by 100, so you have 100.
But now we're talking about error budgets, right? Because we're talking about a combined measure of errors and latency.
Yeah, but
Yes.
we do the same thing for our SLA, like for our availability, service availability.
Yeah, it's like the way to think of it, Jakob, is like you have total requests on the bottom and then good requests on the top. And normally good requests is like an integer, 1 or 0. But in our model, the bottom is actually 2, and then the top is 0, 1, 2, or 0, 1, or 2.
Yeah, so that's why I'm using half instead of
Yeah.
Yeah.
So we because we have two different gates that people go through, right? And obviously it's just like a different denominator, so it kind of comes out slightly differently.
Is that on purpose, or is that because it was easier to calculate it this way?
It is easier to calculate, but I think it has benefits as well. And I'll tell you the main benefit. Like if we just had a single, if we were doing it like the exact way of like the SLO book and everything like that, we get one SLO, and that represents errors and latency, right? And I think that we have different failure modes when we have 500s and when we have things slowing down. And even though they are sort of both bad user experience, it does help us to kind of dig into the problem better.
But that's not what error budgets are about. Error budgets are about if you know, are we doing a good job? And
Yeah.
if you're saying dig into the problem, that is us infrastructure analyzing an incident.
Take a
But
look
we're
at the
using the same
equation that
signal
I
for both.
pasted just now in the demo doc. That's the equation we're talking about. And we're using the same for both.
But almost like, I don't understand why we use, like, if we want to understand an incident, we almost always need to drill down and look where it's coming from and what's going wrong.
Yeah, we could, I mean, we could merge them into one gate, right? And the gate is either 0 or 1, and you score 1 if the server fails with a 500, or the server fails with a 500, or your request takes longer than a certain amount of time, and that's basically bundled up. If you get a 400, it doesn't even count in the proper model, right? But at the moment, because we're using two different counters in Prometheus, we are, and we can't kind of, I don't know, align them if you want. We're just basically counting out of 2, and then those two values at the top are kind of independent of one another. If we wanted to go the full hog, I think the only way you could really do that is by changing the code so that effectively we have that count where we count up on every request that's not a 4xx, we count up at the bottom, and then on every request that's not a 4xx that takes less an amount of time and is not a 500, we count up 1 on the top. And that's the only way, and that's like a Ruby piece of code. And that's the only way you could really do it in Prometheus effectively for latency and valid requests, if you wanted to stick to the like proper definition. But I don't know if we want to do that.
Yeah, I'm also a little bit lost on what problem we're trying to solve. I guess, I mean, what Bob was saying, that we should treat 500s and exceptions the same way. It shouldn't depend on where our middleware sits in Ruby, whether something gets counted as a 5xx, right? Because if something turns it into a 5xx before the middleware, then it shouldn't fly by. And then if it's an exception, like that ordering shouldn't matter, but that's straightforward.
I think the short question is, do we want to count aptX for 5xx's for both, in both cases? Like right now, we're doing 2 different things. Which of them is right in the short term?
Okay.
Is it
But
easier?
isn't the answer there that 5xx does not count towards? Okay, and then we get back to, we don't like what counts towards what, and we get back to the complicated model. Yeah.
Should they be the same or not?
I think the easiest thing to understand is the first table that Sean put in there, the smaller one with 2 rows. That sort of sticks with the model that we've currently got, or at least the internal.
The idea
like,
of that is to like say this is what we do. Yeah.
Yeah, and that like without kind of going into like a whole different world of unifying them or anything like that, like that is definitely, if we can make sure that that's the model that we're following, then that's the best for now.
Because I wonder if then we should just change this to just put that in the docs and say, like, to people, this is well, maybe not exactly like that, because like Jakob said, half a point is kind of confusing, but yeah, something like that says like, these are the axes your request is judged upon. And, you know, you only get full marks for being fast and successful. You get half marks for being one of those two, and you get 0 marks for being neither.
So just, I haven't read through this whole thread, but what a handled error is
Sorry,
it a
by handled
500
error,
still?
so this change makes it so that any error that bubbles up, like Jakob mentioned earlier, any error that bubbles up out of Rails and then gets handled, handled out of the application and gets handled at the Rails or rack level, gets 0 points, even if it's fast.
Okay.
No, is that right, Bob? Or does it just not get recorded? It doesn't get recorded, so that bottom table is wrong.
Yeah. So where we're at now, for if something raises in the code, we will track it as an error, but we will not record aptex for it. We will not record the duration for it. If the code says, the Rails app or the rack app says return 500, we will record both.
So would it help in that table if on each of the things where you've got a 1 and a 0, you actually say 1 out of, it's
2 out of 2,
2 out of 2,
yeah,
1 out of 2, because in that other one it would actually be like half out of 1 out of 2 or 1 out of 1,
or 0 out of 1.
Yeah. And that would maybe explain it a little bit better if you kind of said how many of the gates, because I think the problem is one of the gates is getting skipped. Right?
Yes,
and that's the bug.
The bug is very clear. Like it shouldn't. We have code at the level of application controller that, like, where does a GitLab 503 come from? I think that's in application controller.
Yes, it is. That was the thing I mentioned. Although I didn't link to it. Yeah, because
so a GitLab 503 is just an exception that we happen to turn into happen to catch in the application controller, and then our middleware sits around that. But then there's other things that don't get caught until later. But they're not fundamentally different from a gRPC exception. They should all be treated as a 5xx. So that is a straightforward bug.
So so that should raise, I think, like instead of rendering it as a 503, because we wanted it to be a 503.
But then we'd need to know like an outer middleware, like what to do with this specific exception and to return a 503 instead of a 500.
Rails has a thing for that, like a mapping you can write out. I've looked into it with Mario, who left the company like a year ago, I think, but that doesn't exist.
He enjoyed it that much.
Yeah. No, something was weird there with our stack that didn't work.
So, so either we can refactor the way we handle exceptions everywhere in the app, or in the measuring middleware, we can look at the return value of call and look at the number and say, oh, it starts with a 5.
That's very close to the question I want to get answered here. Like, right now we have a thing where only a certain type of 500 gets handled. Should we change both of those?
What do you mean certain type?
Because certain type, as in render a 503 versus raise something.
They should get treated exactly the same.
Yeah, they aren't, I think, now.
But I mean, think about the rest of our observability stack. They don't know the difference between these things. If you're at the level of Azure Proxy or Workhorse, it's a 500.
And also from the user point of view, like, remember, we should be always thinking about it from the service. And that's internal. Like, we really need to,
even from a developer point of view, though, like
that's what you mentioned.
This is a pretty minor distinction about like where you generate that 5xx error code, right?
Yeah, and then the conclusion is also for those things that result in a 5xx, regardless what it is, we don't record the duration.
We do whatever we do with an exception.
We don't record the duration.
There.
So we don't already do. Are you saying we aren't going to, or we don't already?
We do for one, we don't for the other.
Yeah, and that should be. So we need the 2x2 table, not the 3x3 or 2x3.
But we can handle that in the middleware as well, right, Bob? Because we know what the status code.
Yeah, we know what the status. We just need to move the we just need to move, there I go again, because I just moved something, but like we just need in the rack request middleware, the one that we use for entire observability stack, we need to move the AppDex measurement to the bottom and check the status code there.
Yeah.
So we recorded. No, actually we need it. Do we want to record it or not? I still haven't had an answer to that actually.
So
Maybe we should
I
put
think
the table in the docs as it is now. Put the table in the docs as what it should be, and then once we've documented what it should be, we should go and fix it to match what the docs say. How about that?
yeah. I also think it might be really helpful just putting like a good request, bad request without all the different status codes, or maybe status code class. So that's what Google do a lot. They have the 2xx, 3xx, 4xx, etc. And then putting that on the latency, and then we can kind of progressively bring it in, right? It's not like we can have two different recording.
We'd start recording it on the lower cardinality metric first and just see what we get out of that. Is that what you're saying?
But we have that on the lower cardinality one, don't we?
Oh, do we?
We don't. Yes, no. I don't know. I don't think so. No, we just have the method. Get post kind of thing.
Yeah, so we add 2xx, 3xx, 4xx.
Yeah, because we don't, for the latencies, we don't. The other thing that we kind of giving developers a free ride with at the moment is 4xx responses that come back really quickly and say you're not authenticated are counting towards your good error budget, which is wrong.
Yeah,
But
they're 2 thumbs
that's
up.
a question for another time. Yeah, exactly.
In some cases, it's not wrong, but
yeah.
well,
But
because
you
with Git HTTP, it's actually very good because Git HTTP will always probe and get a 401 before it makes the next request. So that first 401 needs to get done with as quickly as possible.
Okay.
But that is a very specific thing that we do have in high volume.
Yeah. But I'm less worried about that now. Like I think let's rather, they're two separate problems. So like let's try to keep them separate because it's a little bit intractable at the moment, I think. But certainly putting that graph of the gates and how they add together. Yeah.
Yeah, I kind of like the idea of like 2 out of 2 thumbs, 1 out of 1 thumb.
Yeah.
I don't know if we should actually put that in the docs, but
one thing that I now still want to point out with the 2 tables that are mentioned there, we are currently doing the bottom one. For everything that counts, like everything that counts for infrastructure, we're doing the bottom thing.
So we intend to do the top one, but we're actually doing the bottom one. Is that right?
We like for the service SLIs, for the not there, like forget about error budgets. We are doing the bottom one.
Okay.
Yeah.
So we don't want to do that anymore. We're going to change that. We're going. Yeah. Okay. Got it. I know.
And I think everyone's mental model, at least the people who've thought about it, the mental model is for the majority of people is the top one. So we should definitely bring it in line with that.
Got it.
Awesome. Bob, you must go look at the OpenSLO's spec that's coming together, and everyone actually.
I saw that you mentioned that somewhere that you were getting involved in that, but
that was announced yesterday. So it's kind of interesting because so much of the stuff that we've spoken about, and I think especially in the M staff, there was like a year of discussing occurrences versus time measuring, and all of that stuff is kind of, you can see a lot of other people who have had the same kind of discussions, which is kind of nice to see that how similar things are. Anyway.
So Bob, do you feel like you got the answer?
Yes, but I'm going to do what Sean mentioned and just see if we can, like, I don't know where that documentation lives, but I'm going to add it to the documentation first, and then I'm going to ping someone else from the team and say, that's
So
it,
we-
right?
I would put it on the dashboards for stage groups page. I don't know if that's like the canonical
no,
place, but I think it's the place where that's the
think that-
audience that we want to reach, right? Like,
But it came up through the discussions for error budget, but I'd rather, like, I think the other one is more important for the overall GitLab.com availability. And we want to, like, we've decided that we want to do the same thing for both.
yeah.
So
Definitely.
I can start by documenting it on the error budget one, but it needs to go somewhere where we document how we.
Oh, sorry. I meant, yeah. Well, the error budgets are documented on the dashboards for stage groups page, right? It's not just about error budgets. So that's what I was talking about there. Is like, this is sort of where we lead into talking about like what the metrics that we use on GitLab.com are to developers. So that's why I was thinking
the
there.
page that I linked could mention this as in if your request is an error, it will not count as an apdex. Like there will not be an apdex like in the equation that I linked there.
Mm-hmm.
And we could add that to the doc there.
Yes, I was also going to add the apdex thresholds to that page today because a stage group requested it, and it's totally reasonable because like they're like, what means apdex? Like
check them for all of the components though, because there's.
Yes, I will do. Yeah, because obviously I've been using 1 second as a shorthand because I mean for Puma, but that's not the only component.
That's not true everywhere. Okay, I know what to do.
Great.
Are you going to put that the table in with the out ofs, because that'll really help explain it as well.
You know what? I'll do that, and then I'll mention you on the merge request, and you can see if that's what you had in mind.
I'll update my comment to sort of demonstrate that as well.
Cool. Thank you.
So, like, I really think it's important that all of the different definitions are as close to being in line with one another as possible. Like, so the ones that we use for service monitoring and the error budgets are kind of, we actively try not to diverge those too much, and where they are diverged, we bring them back in line because it's just cognitive overhead when that happens.
The thing for Puma durations is, like, as you've seen and you've mentioned it in one of the issues as well, like we can't add the feature category label and the root label, or like the action label, or whatever that's called, controller action. We can't add that to the one we use for we can't add that to the one we use for measuring Puma itself, because it will hurt the histogram. Do you have any idea on how, like, should we work towards trying to unify those somehow by removing something
I mean,
else?
maybe let's get this done here, but maybe like a longer term thing is just to like actually start introducing another metric that is the it's basically a 1 and a 0 counter, and then the flexibility you get there. This was actually in that SLO monitoring v2 proposal, but the proposal there is that you actually give the teams the ability to define those thresholds themselves in with a thing, and then it's actually in the code as opposed to it being on outside the code.
Then controllers and requests are not just tagged with the feature category, but also with
tagged with the latencies.
Threshold. Yes,
exactly. And then
we just count them, and we don't have a histogram with.
We don't. We just count the top and the bottom. That's all we're counting, and then the rest is up to them to kind of dig in further.
Like we just count, we count request was performed, and then we count request was successful or not.
Yeah, request was good, request was bad. Total requests, good requests. And then we don't have to kind of tell them what thresholds we're using, because they're defining the thresholds. The only thing is to make sure that they don't just set 60-second thresholds for things that they want to fix their error budget on.
Yeah, we can validate for that kind of things.
Yeah.
Like we can.
Yeah,
we could still. I guess we would still need an independent thing that shows us what the actual threshold is.
Mm.
Well, you can set thresholds within this range
Well, actually, I didn't mean what the actual threshold is, but some way of saying this feature category has requests that are this latency. So
Yeah.
if people are gaming the system, it would float up.
I mean, you could just put that in another metric, right? And so it is, because you'd want it in a metric because you'd want to be able to put it on graphs and stuff anyway. So it would be good to expose what that number is, endpoint latency threshold 60.
Right, and then you could even do things like calculate the number of requests and the threshold, and say, okay, so this is projected to consume an hour, this many seconds. So this is a ridiculous reservation.
Budgeting,
They're basically making a latency reservation for a certain thing, and we could say, why are you reserving so much latency for yourself?
That's very clever. Yeah. Quota management. But I mean, I also think like maybe that is, I don't know if it's like really, really hard to kind of go to that, but I suppose it would be. It's a whole nother project really. So it's not something we want to do now, but it's something to keep in mind.
I'll start with the tables thing. That was a good idea.
Long term, having stage groups own more things is just is a good idea, and this general model of
it did come up in a discussion.
Is better.
It did come up with a discussion in the stage groups already. Like, can we set our own thresholds for this? And like now the answer is no, but it should be yes.
Yeah, and that would be the way to do it.
I'm going to write something about this discussion because I think the whole counter ID is much better. Much better. Like we should try to go there.
It's the correct way to use Prometheus.
So I'm also wondering whether, like, if by the time you've done, because I heard several mentions there of, we'll just have to change the whole monitoring, the observability middleware in Rails. Maybe it would be no. Okay, you don't think that it's?
I'm not right now. Yeah. I think we need to add the new metrics and then see what we can remove of the old ones, and then maybe get rid of GitLab transaction things again.
Yes. Yeah. Cool.
Short term, I'm not going to change a lot. Just change the that we don't care anymore how an exception was raised, how an error, how a 500 was raised.
Yeah. Definitely.
And on that note, I hope that you have a good afternoon. This is a great discussion. Thank you very much.